right, so this is section 5.1, and the title is going to be Quadratic Functions, and I think we're going to be here for a few days. Okay, so, because there's only, out of your textbook, this is the only section that covers entirely quadratic functions. So expect that if we're going to do these kinds of functions, we're going to be here for several days. Okay. The first thing that I want to talk about is a quadratic function. A quadratic function typically graphs, well, always, I'll say always, a quadratic equation graphs a U-shaped function called a what? Parabola. A U-shaped function called a parabola. Okay. We usually see the quadratic equation in the form of, if it's the toolkit function, y equals x squared. Y equals x squared. So anything that has a leading degree or a highest degree of 2, those are quadratic. So quadratic sounds scary. All it means is x squared. These kinds of functions. Okay. In standard form of a quadratic equation is f of x equals ax squared plus bx plus c. And I actually think you should be really familiar with this by this point in the school year because we've solved quadratic equations a lot. You've seen this over and over and over again. But these particular parameters, that's what A, B, and C are called, they're parameters, they tell us things about the graph of the equation. So whereas you've looked at this as, well, I solve for x, I solve for x, I solve for x, we're looking at this now as, what does it look like? What is the shape? And how can we tell the shape based on this information? Okay, so a few pointers that I'll give you before we really get going here. If I'm going to talk about A. If the letter A, or the number A, number in the letter place, if A is greater than 0, we're talking about a positive number. If A is greater than 0, the parabola opens up. Like a cup. Looks like it would hold water. The parabola opens up. If A is less than 0, and this is going to be like a negative number, we see a reflection. We've talked about this in our transformation unit. The reflection. So the parabola opens down. Parabola opens down. Like a frown. So those are two kinds of things that could happen to A. It could be positive or it could be negative. What else could A look like? It could be a fraction. Okay, so let's say the absolute value of A is between 0 and 1. That's a fraction-y kind of number. Why did I say absolute value? Yeah, because I already handled the negative. I already know what happens if it's reflected. This is talking about the number itself. If the number is between 0 and 1, that's like a decimal, we have a wide fraction, or let's put it better, a vertical compression. We'll see a vertical compression. We're not going to shame this parabola, but it is fatter. Vertical compression. So it got squished a little. If Last thing. If A, the absolute value of A is greater than 1, that's like a whole number, what do we see? Vertical stretch. Good. Vertical stretch. And so then we would see like a tall and skinny kind of parabola that got stretched upwards. Yeah? Okay. Okay, the next thing that I want to talk about is called the axis of symmetry. The axis of symmetry. Anybody know like a good solid definition for axis of symmetry? Both sides are mirrored? Good. So this is kind of the dividing line in the parabola that splits it into two symmetric pieces. Okay? We're going to label that in just a minute. But I want you to see that the axis of symmetry is located at x equals negative b over 2a, meaning this b and this a value from your standard form. The axis of symmetry is located at x equals negative b over 2a. That's kind of the crux of everything. If you can find the axis of symmetry, then you can find everything else. It's pretty cool. Axis of symmetry is located at negative b over 2a. Okay. All right, so I think that's enough to get us started here. Let's do example 1. Axis of symmetry was located at x equals negative b over 2a. So here's a parabola. Actually, this is just a coordinate grid. It's going to be a parabola. Just a second. There's a point at 3, 1, and there's a point on the y-axis at 0, 7. 1, 2, 3, 4, 5, 6, 7. And there's another point at 6, 7. A matching point at 6, 7. And then we've got this parabola that's kind of drawn through these points. Can you see it? Everybody good? Okay. So the first thing I want to do is I want to look at this picture and I want to find where is its axis of symmetry. Where's that fold line that if I folded the parabola right down the middle of that line, I would see two equal pieces on both sides. Where is that? X equals, where does it look like it is on your picture? 3, right? X equals 3. So that's one cool thing. The axis of symmetry is a vertical line every single time. The axis of symmetry is a vertical line. And so it has an x equals equation. Axis of symmetry has an x equals equation. This axis of symmetry is located at x equals 3. Has to have x equals because it crosses the x-axis. It's a vertical line. We talked about that yesterday and the day before, vertical lines. Okay. And then I keep hearing Bryson say the same thing. So I'm going to listen to him, and he's right. The axis of symmetry gives us the location of the vertex. Okay, this is called the vertex. The vertex is always on the axis of symmetry. You might want to write that down. The vertex is always on the axis of symmetry. Every single time. It would be kind of silly to say that the axis of symmetry is in the middle and the vertex is over on one side or the other. It wouldn't make a whole lot of sense. So the vertex is going to be the extreme value. Okay, it's either the maximum value or the minimum value. And that's going to depend on whether your parabola opens up or down. If your parabola opens down, your vertex is a maximum. If your parabola opens up, your vertex would be a minimum, right? You can see how that would work one way or the other. Just depends. Your vertex is always located on the axis of symmetry. So once you have that particular number for your axis of symmetry, all you need then is the y value. You take this x number and you plug it in and you find what's the y value for the output. So when x is 3, what's the y value for this particular dot right here? 1. Boom, vertex. It's the highest or the lowest point. Are we cool here? Cool, cool, all right. Y-intercept. The y-intercept, this is going to be where the graph crosses the y-axis. Where the graph crosses the y-axis. This is going to be located at 0, 7. 0, 7. I want to reiterate, to find a y-intercept, and you're given a function, what could you do? How do we locate the y-intercept? Plug in 0 for x. Plug in 0 for x. So your y-intercept is always going to be found at f of 0, comma something. Sometimes 0. Could be the origin. Okay, so to find the y-intercept, that's how we do. There's another facet of this graph that I'm not seeing on this particular picture, but I could have. What am I talking about? X-intercepts. Good. X-intercepts. And so X-intercepts, also known as what? Zeros, roots, solutions. There aren't X-intercepts on this picture, right? In this case, we would say there are none. But we'll talk about in just a second how to find those. We know to find a y-intercept, we put 0 for x and solve for y. To find an x-intercept, what could we do? Good. Set f of x equal to 0. And then we have some options there. Set f of x equal to 0. This is quadratic. So we have two options for how to solve a quadratic equation. The first one, and our go-to and our fastest option, is to factor. Do y'all remember factoring before? What are factors of C that make B? Look here. This is in quadratic, or in standard form. Ax squared plus bx plus c. We'd say what would multiply to make C, but add to make B. Do y'all remember doing that before? We spent like a semester on it, so yeah. So we would want to do here factor. And if that doesn't work, what's our second option? It was long, and you learned a song. The quadratic formula. So you can set x is equal to, given a, b, and c, how does it go? Negative b plus or minus b squared minus. That's it. So you got two options for finding x-intercepts. You can either factor, and I would try that first, or you can use the quadratic formula, and we can find those zeros. And understand that you may not have them. This is a perfectly good parabola that does not have any x-intercepts. So we learned something, the discriminant, that would tell you whether or not you were going to have x-intercepts. Do y'all remember? I bet you don't. It's okay. The stuff under this square root sign. If this stuff under this square root sign came out less than 0, that was negative. Can I square root something that's negative? So those were imaginary solutions. So we had no solutions. Do y'all remember? What if it equaled 0? How many? One solution. And what if this discriminant number came out greater than 0. How many possible solutions? Plus and minus. You have the plus option and the minus option. 2 solutions. Is this ringing a bell? Okay. It's been a long time. Okay, I think that covers us. No, we're not done. Are we done? No. I think we're ready to graph one. I think we're gonna actually try one here. This is example 2. Yeah. If your discriminant is greater than 0, you might have 2 solutions. Okay, so we're going to graph f of x equals x squared plus 4x plus 3. Graph f of x equals 4x or x squared plus 4x plus 3. And I'm going to put my graph over here. I'm going to do all my work over here on the left side. So the first thing I like to start with is my y-intercept. I always start with my y-intercept, which means I want to plug in 0 and see what's my output. What'd you say? 3. If I plug in 0 here and here, it zeroes out both terms. And I'm left with a 3. So f of 0 equals 3. Let's go ahead and plot that point. F of 0 equals 3. The next thing I prefer to find is the axis of symmetry. And the axis of symmetry is located at x equals negative b over 2a. In this particular problem, b is going to be that 4. And a is going to be what? 1. Very good. So we're looking at the coefficient of x squared. Remember, this is in the form of ax squared plus bx plus c. So that's where we're getting those values. So x is equal to negative b, that's negative 4, over 2 times a, which was 1. Axis of symmetry comes out to be at x equals negative 2. So you're going to go ahead and sketch that out on your picture, and that's a vertical line that goes all the way through the x-axis. X is equal to negative 2. And my favorite, after I know the y-intercept and the axis of symmetry, is to mirror that dot that was 2 away and up 3 from the axis of symmetry. I want to mirror that on the other side. I want to go 2 to the left and up 3. It's a bonus point. You just get to get it. It's a freebie. So if I had a dot at 0, 3, I'm going to have a mirrored dot at negative 4, 3. Everybody see it? Okay. Next, we want to locate the vertex. And again, the vertex is on the axis of symmetry. So the x value for my coordinate of my vertex is that negative 2 that we just found, which is awesome. So all that's left is to go into my function and evaluate output when x is negative 2. What's f of negative 2? Okay, and this is the part where I'm going to allow you to have a calculator here. That's a lot of handwork that we don't necessarily have to do here. We're going to have 4 minus 8 plus 3. I believe our output is negative 1. Is that right? So our vertex is going to be located at negative 2, comma, negative 1. Is that a maximum or minimum value here? It's a minimum. You already have 2 points higher than that, right? So this is going to be the minimum value. Who can tell me why it's a minimum? Because it opens up. What tells you it opens up? What's A? A is positive 1. A is positive 1. That tells me this vertex is a minimum. Everybody good so far? Okay. One last set of information. I want to know, where does this guy cross the x-intercept or the x-axis? And these are going to be zeros or roots or solutions. You have names for these. Our first step is hope it factors. We're going to set our equation equal to 0 and hope it factors. Are there factors of 3 that make 4? 3 and 1. Nice, right? So 0 is equal to x plus 3 and x plus 1. I set each piece equal to 0 and solve for x. X equals negative 3 and x equals negative 1. These are my x-intercepts. This could get nasty, okay? In your homework, they don't play nice. In your homework, they don't factor, and these are not pretty numbers. So be ready to use the quadratic equation. Be ready to use the plus and the minus option on your calculator. You guys are good at that. But just understand that graphing these is not going to be pretty. All right? These are, though. Ooh, what a great example. So we got a dot at x equals negative 1 on the x-axis and at x equals negative 3 on the x-axis. And then your last step is draw your beautiful 5-point parabola. Everybody get it? Okay. What are your questions? Don't have any? Have you done this before? Okay. So today was kind of the lesson, the background. What are we doing here? Tomorrow you have in-class time, because I know you're going to need a calculator. You have in-class time to get these graphs done. You have 6 homework problems. So 6 of these from start to finish. Okay? You can go ahead and get started on them right now. We've got lots of time before the bell rings. I want you to grab some graph paper up here so that they're beautiful. Okay? All of these points should fit on your grid. Awesome? Any questions?